So this question is asking us which element, okay, if I can just write this down, which element has highest electron affinity. Okay, so that being said, we're giving 5 options. We're given A is xenon, B sulfur, C cesium, D barium, and E copper. Okay, so which of these has the highest electron affinity? So let's look at the periodic table, okay, to find out where these are located. So this is xenon down here, okay. This is sulfur up here. Cesium is going to be all the way over here, okay. Barium is going to be now right next to cesium right there, and copper is going to be in the transition table right here. So to find out the electron affinity, it's quite similar to the electronegativity, but not just quite. The electron affinity can be described as the how likelihood it wants to take another electron. Okay, so with that being said, just based on taking electrons, we can safely say that cesium and barium are going to be out, because if anything, they want to get rid of their electron. Leaving us with 3 choices: xenon, sulfur, or copper. This is where it gets a little bit tricky, because if I remember correctly, okay, so exactly, ionization energy will be something different, and ionization energy is pretty much the energy it would take to remove an electron, and that one for noble gases is going to be the highest typically, because they have no reason to remove it. They're actually completely stable. They prefer their octet rule. It's going to be really hard to take away an electron there. But that's not how electron affinity works. Electron affinity now is talking about how likely is it to attract another electron, okay? So because of that, xenon as well, because it's already full, it has no reason to attract more electrons. So xenon is out, actually. Okay, so now it's just going to be between sulfur and copper. So copper is right here, okay? And it's, as a transition metal, it's valence electrons are kind of skewed. Like, we don't really know. But what we can say is that we can kind of treat it like in terms of having the valence electron of like the first 2 columns, because that would be, I guess, the best way to see that copper doesn't really have that many valence electrons. And because of that, sulfur, as you can see here, is pretty down, not down, but pretty to the right of the periodic table. And it also supports that, because now it's all the way there, 16th column is most likely going to have 6 valence electrons. So definitely would like to just add another one, because it only needs 2 more to finish the octet rule. While copper, we don't know how much, but we can assume it's quite a bit. So with that, sulfur just becomes just more prepared to take more electrons. And I think that's what electron affinity refers to, just like the likelihood that you would take another electron. And sulfur has many reasons to, considering that as it takes electrons, it becomes closer to the octet rule. So that is what we have here, of which element has the highest electron affinity. Let's see how we did. It does say indeed that sulfur, an electron affinity is defined as a change in energy of a neutral atom or electrons added to the atom to form a negative ion. Okay, so it still exactly deals with, I guess, electrons coming in, but exactly like it's more of a process here, as I explained, to say that the amount of energy released when an atom gains an electron. So electron affinity generally increases across the periodic table from left to right, okay? But the only exception, as we said, was kind of like the noble gases, because they can't even add that electron to be able to even like register. Like noble gases are completely already filled, so they have no reason to bother. And because of that, there's not much, if there's any, energy released when noble gases are filled with electrons. So now with this, as we've seen, sulfur should be the only choice, because there's really nothing else we can do. So copper's in period 4, sulfur's in period 3. That shouldn't be correct. I think they meant to say that sulfur was in period 16. Don't really know where they got this 3 from. Maybe it was scandium they're looking at. But overall, though, they did lower in the periodic table the high electron affinity. So the atom with the highest electron affinity among the options is sulfur. So, okay, period is referring to like the horizontal part. So with that being said, which element has the highest electron affinity? It is indeed sulfur, and this is correct. Okay. So now question number 16.